Altair SimSolid. It's an extremely revolutionary new type of simulation structural technology that Altair has developed. It really is a groundbreaking package. We're very, very excited about presenting this. Myself, I'm Ben Gervais. I'm an application engineer and also managing partner at Futurescape, and also we have Ali, who's also an application engineer here at Futurescape. We're going to start with a PowerPoint slide giving an overview of what Altair SimSolid actually is, and then after that, after about 10 minutes, we're going to hop into the software itself, and Ali's going to present a couple different model examples to show how the technology works. Before I continue, I just wanted to mention to everybody that if you guys have any questions or anything like that, feel free to type it in the chat box. And at the end of the presentation, we can actually do a Q&A and answer any questions live on demand as we go in the end. Okay, so what is SimSolid? Basically, it's a new type of simulation, like I said, for structural simulation. And the reason why it's so revolutionary is, one, it will work on original CAD geometry. As some of you may have been familiar with, having done simulation in the past, typically you have to prepare the geometry, have to do a lot of prep work before we actually go and get the simulation results. And then also after that, you typically have to work with some type of mesh or simulation type simulation type mesh to basically make sure that you're getting a clean result at the end. The real point of this is you can basically get the simulation results within minutes. Moving on next, put more simply, basically SimSolid can, one, be able to take in a large assembly and basically be able to create those connections within seconds. It will go in and find all the parts that are close or kind of not quite joined together, but touching, and it will try to identify what type of connection those parts actually have. Secondly, again, like we said, it works on fidelity CAD models. So you can bring and import any CAD geometry into the SimSolid package directly. If you have any updates or iterations on that CAD geometry, you can also bring that CAD geometry into the package, and it will automatically update and still maintain the settings and connections you had previously. Thirdly, no meshing. You don't have to worry about setting up your mesh. You don't have to worry about the type of geometry that you're meshing. You don't have to worry about the types of mesh. SimSolid will go in and take care of that by identifying the geometry and go in and use its new revolutionary proprietary algorithm to basically figure out how to do the simulation in the background. Again, you can get results in minutes, and we're going to demonstrate that here at the end of this presentation. So here's an example of why SimSolid is wonderful. Here's a very large assembly. As you can see, it was set up and got simulation results. We were able to solve this literally within minutes. The whole point here is, for example, you'll see here the statistics on what the part or what the part count was. It was over 2,000 parts. It had 387 bolts. And it's a very large, complex model. So it was able to bring in that geometry and basically automatically do the setup and then do the simulation within minutes. Here, going into more detail, some of the things that people dealt with in the past for simulation. I did simulation for many years a while ago. And these are some of the things that I found quite difficult when I was actually doing simulation. One, you'll see that you might have assemblies with big or small parts that are connected together. That can often cause problems with mesh disconnections, or basically might increase the mesh density, which will basically increase the solve time. And you can also deal with thick or thin parts. Here at the bottom left, some small geometry features. So sometimes you have holes or pins or small radiuses that sometimes you have to simplify to be able to make sure that your simulation works well. Again, SimSolid can deal with those types of geometries very quickly. Part gaps and overlaps. Sometimes you might have parts that are going into each other, or they're not quite touching, and you're trying to make those connections in the simulation. Again, you don't have to worry about that because there is no mesh. SimSolid goes and figures out those connections and adjusts its estimation of what that connection is, regardless of what the geometry is. The top right there, you'll see also what's really wonderful about SimSolid is you can do some very complex geometry. As you can see there, there's a lattice structure there that's meant to be 3D printed. There might be situations for some people, maybe biomedical or 3D printing or other types of realms where you're dealing with very, very fine detailed geometry. Again, SimSolid can go in and basically deal with that type of complexity. And the last here at the bottom right, you'll see that there's also odd phase transitions or small splinter faces. Sometimes you'll have these very strange surface anomalies that you need to deal with that can cause sometimes some really weird mesh transitions. Again, SimSolid can deal with that. And so there's the typical pains that I used to deal with in the past when I was doing simulation, and SimSolid basically takes care of all that automatically. What are the steps for SimSolid? First off, you bring in the geometry and it'll convert all the facet volumes, meaning it will go in and identify the types of geometry that are in there. Next, it will classify the types of geometry you have. So you'll see, for example, it will identify if there's nuts and bolts, if there's thin sheets or sheet metal. It'll also find if there's through holes or all the different types of classifications of parts that you might have in there to make the simulation more accurate. It'll also identify all the connections. So like I said before, you can come in, find all the contact regions between parts. It'll identify different types of contacts. You might have maybe bonded connections that are maybe welded or whatnot, or maybe there's sliding contacts between parts, and it'll try to identify those automatically, and you can always adjust them manually after if you like. Lastly, all you need to do once you do the setup is select the type of analysis and run your model to get the results. Here's an example of what the technology of SimSolid is doing in the background. Here's an example of a hole, maybe it's a small hole in a part and whatnot. It might introduce some stress concentrations or risers. So it'll basically do an adaptive pass going through the this hole to find out like basically what type of error calculations there might be, and it will do an adjustment on the second pass to be able to make sure that the error is reduced in that model. What are some of the features that SimSolid has? We can do modal, linear statics, obviously your vibration response, thermal stress as well. It'll actually do bolt pretension, which some people in the structural simulation world really like. With the materials here, isotropic, obviously we can do isentropic, we can do rigid, we can also do fluid bodies, which has been introduced, orthotropic. And with the connections, we have lots of different types of connections. This is something we're constantly working on, and SimSolid is being developed literally very rapidly. So you'll see here, for example, you can do separation with friction, bolts, spot welds. We've introduced seam welds, bushings, rivets, adhesives, and joints. And for the results, you can do different types of presentations to show your clients what type of results you had. And you can do reaction forces, you can do obviously your stress plots, mode shapes, and you can even put in that we added in contact responses and strain energy density. One thing that some people ask us is who is using SimSolid. For those of you who've not heard it, there's lots of different customers adopting this. You'll see here up there, for example, there's Whirlpool, Sharp. You might see maybe some of your customers or suppliers in here. And SimSolid really has been really revolutionarily helping some of these clients really reduce that workflow for getting those simulation results. Here's one example of one of our customers that's using Serapid. They create construction type assemblies to be able to help with the construction industry. Here you'll see there's basically a very, very large assembly. They are able to solve this literally within minutes. It's a very complex model to deal with, so with the part count, SimSolid can handle those very large part counts, be able to solve those large assemblies very quickly. Beyond large assemblies, we also have Western University. For those of you in Ontario that are familiar with Western University, they do a lot of biomedical research. As you can tell, they take in those MRI scans, and typically these are very complex models. There's porosity in the bone structure that they need to deal with, and so it can take in that very complex geometry, and SimSolid can get those results very quickly, where traditional FEA, they had a lot of difficulty, sometimes not even able to solve these models. Why SimSolid in a nutshell? Basically, we can eliminate geometry, simplification, like I mentioned before. We can do very large assemblies and very complex assemblies, and you can basically get those results literally within minutes. So now we're going to hop into the actual software simulation. Like I said before, during the demonstration, if you guys have any questions, feel free to put those into the chat comments, and we'll try to do our best to answer at the end of the presentation. Go ahead, Ollie.
Thank you very much, Ben, and thank you very much, guys, for joining us. As Ben told us, that SimSolid is a quite powerful solver, and it operates directly on an unsimplified CAD, that we just did not need to simplify the CAD, and we just do not need to worry about the mesh or creating the mesh. Only the thing we need to do is we need to import the model, define the type of analysis we wish to perform, and we have the results. Within these seconds in which I was trying to tell you what SimSolid does, we already have a solution for this model analysis. It is not a small assembly. As you can see, we have almost 33 parts over here, and we are able to solve this within few seconds. So let's start from the very beginning and see how do we do that. So let's say you are a fabricator and you have a contract of designing a pull-up bar, and the manager comes to you, and you are a designer, and he asks you to design a pull-up bar. So over here, let's say I have designed the initial conceptual model, and I just go ahead and import that model in SimSolid. I want to check how does that model performs to the load conditions that we have. As you can see, we have imported the model in SimSolid. This is the basic user interface of SimSolid. We have basically two toolbars. One is the horizontal toolbar, in which we have different options to open the files or just to zoom in, and the end we have the type of solver we want to use. For example, we want to go for a structural analysis, we want to do a modal or dynamic, thermal, or fatigue analysis. In this case, I'm just moving on to our static structural analysis. So in assembly, as you can see, we have imported the 33 parts over here. As soon as we import the model in SimSolid, there is an AI algorithm that is working behind the SimSolid that tries to identify the type of geometry that we are trying to import. So as you can see over here, we have hex, nuts, and bolts, which has been classified with SimSolid. This will be used further on in our analysis, as we will be able to do nut tightening or bolt pretensions. Now the next part is creating a connection. As we might know, there are 33 components over here, and it would be quite difficult to just create connections over here. So over here in SimSolid, it's quite automatic. You just need to click the automatic connections button, and over here we have the gaps and penetration. As Ben in his presentation told you, that even if you are in a conceptual state of the design, you might have not designed the model into a perfect sense. There might be gaps and there might be penetration, because you are in a conceptual phase of your design. You might have not given that much detail to your model. So in this phase, SimSolid works into play. So if even you have the gaps or even you have the penetration, you can just give the tolerances for these, and you just need to press OK, and it will define the connections automatically. For this model, as I pressed OK, it has automatically defined 70 connections. So now let's move on to creating a structural linear analysis. In structural linear analysis, we have multiple boundary conditions that we can apply. Over here in the vertical toolbar, we can have supports of different types. I'll just move on and just give a immovable support to this ends and press OK. Now we need to put on the boundary conditions. So let's say there is a person who is of 75 kg and who is trying to perform exercise on this very bar. So I'll just go ahead and create the forces. For 75 kg, it will be 750 Newton. I'll select the faces and give the direction as minus 750 and press OK. Now we have created one load case for this very model. But the thing is, as you can know, as we know that there will be multiple cases through which a person can hang through this bar and perform the exercise. So we need not to again give the boundary conditions, give the immovable support. We just need to copy this load case and just need to change the faces on the body to just simply change the load case. Over here we have defined the load cases. Now the thing remains is defining the material. So over here we have a material library which is quite extensive. You can select material from quite range of material from here, as you can see. For this case, I'm just applying steel to all and just clicking on to solve. So as you can see, we were able to solve this model. We will be able to solve this model within a minute. Now, if you take if you haven't have this technology, we might go to a CAE and it might take a week or so to just analyze this and to take the response. How does the structure perform? But in SimSolid, even after design phase, even a design engineer is able to see how my model is able to perform and make the changes, required changes immediately within few minutes or hours, I'll say. So over here we have the solution for our boundary conditions on our model. If I just go to displacements, here we have the displacements. We can have the animations. If we want to save this animation. Here we have a bookmark browser, which gives us capability to save these as a videos. And I selected it. It will take a while, and these things will be saved. I'll just give you a view how our videos look. So here is our video. So for presentation sake, if you want videos, pictures, quite fast to just put on the boundary conditions and perform. Now say you have performed the analysis and we know how our structure behaves. Over here we have the displacements. We can see what is our, if we do not want to extrude the deformation, we can click here and see the actual deformation that is occurring. Also, we have stresses. There are various stresses that we can look upon to, say von Mises stress, principal stress, or shear. Here we have von Mises stress. As you can see, we have the stresses quite much over in these portions. Apart from stresses, we have strain, we have energy. And let's say you want to pick an info and see how is the stress at a particular point. So you can just pick a point over here and see what the stress at that very point is. If say you do not want at any point, you want it in a line. So here we have a feature on which you just need to select 2 points. And here we have given 20 points. It will divide that line segment into 20 points and give you the results. Now these results can be further saved upon as a PNG, as a TXT or PDF file. Then you can take for your report or so. Apart from these results, we have over here bolts, nuts and bolts forces. As SimSolid was able to categorize nuts and bolts separately, so here we have the feature through which we can see what amount of forces are acting on our bolts. At this phase, we can select which kind of nut or bolt is suitable or not for our case, our specific case. As you can see, here we have axial forces, shear forces, bending moment, everything that we need. And we can save this into CSV file for further processing if we need. Apart from these, we have the reaction and contact forces. As we have two contacts, as we have supposed that it will be contacted through a wall for immovable support, we have two contacts over here, and we will be able to know what is the forces and what are the movement that will be acting. Apart from this, if we just want to just emphasize only on a one body in the model, we can select that very body from here and see what are the different forces acting upon that very body at different points. Similarly can be done for the structure load case 1. We can see each and everything that we want and we can take the data out. Let's say you have analyzed this pull-up bar and you found out that, yeah, the stresses are quite large over here. So say we need to bring more support for this model, then I'll just go to our CAD software and quickly go ahead and change some of the parameters. I'll say I have made another model that is version 2 of a pull-up bar, and I'll just import it in to see how this one behaves to similar cases. Now, as you see, as I have imported this version 2 of our pull-up bar, SimSolid automatically copies all the load cases, all the conditions that we initially had to this very model. As it identified that these models are similar, what you are trying to do is you just need to compare your previous model with this one. It automatically copies your initial load cases and all the forces and displacements to this pull-up bar. The only thing now you have to do is just to apply material. We need to apply the same material, say, and just need to press solve. Now the question comes, Mr. Ali, that's all fine, but how does it be able to solve this complete structure in very short duration of time? What does it does in the behind? So what's the difference? So in FEA, what a FEA solver does, it divide this, say, this body into very small elements. But in SimSolid, it does not divide this whole body into small elements. It considers the whole body as an element, and it defines complicated mathematical function over that body. And that as we go to the solution passes, there are 3 passes as you might have seen over here. I'll just change a bit so that we will be able to see again. So if I just solve it over here, you can see there are 3 passes. So in the each pass, what the solver tries to do is try to calculate the error. What is the error coming in a body? And if there are some error, it tries to enriches that very body or that very domain with more equations and more degrees of freedom, so that our solution is quite accurate. I'll just go again and give it again 750 and solve. As you can see over here, within a second we were able to do it. It's quite fast. Again, we can just go ahead and see what our forces are and what our stresses are, what our displacements are. Now, as you can see over here, we have significantly optimized our design. So within very short duration of time, we are able to see how our structure is responding to our load cases, and we can make changes in very fastly manner. Apart from this, I just want to show one more thing over here. As you might know, we have created a bonded context for over here. All the contexts here created are bonded. Although you will say we want to simulate a real life situation, what happens then? So over here in SimSolid, we have that thing over here, that is we can simulate the welds as well. So I'll just go ahead, say delete all our regular connections and try to create a weld. And it's quite easy to create welds in SimSolid. I'll just go into group weld. I'll just select our parts and click find welds. It will automatically try to find the welds where it can do welding between different parts. I'll press OK and the welds will be created. Again, if say I want to create a weld here as well, so I'll just go to group weld and select these bodies, find welds, press OK. So over here now welds have been created. I can just again go ahead and create normal connections for other parts and just solve it. So within few seconds, again, we were able to just solve these with welded connections. Now we are quite into the range of what we want to simulate in real life. We would have welds over here, so we were able to simulate welds over here. So now this was a body which was having a 33 parts. Now let's say what happens if we have a body that have more than say 1,000 parts. So over here we have another structure. This structure is quite large and it has, as you can see, various eye members over here. It is a frame and it's quite large. As you can see, we haven't simplified anything over here. Nuts and bolts and all those edges and all those parts are over here. We haven't simplified anything. And let's see how fast does this solver will be able to solve this very model. So again, we'll just go ahead and create the connection. Connections have been created already. So to save time, I have already done it. So here we have almost 6,500 connections. In assembly, if I just go and show you what are, so you can see there are about 2,162 parts in there. And SimSolid has identified 387 bolts. So I have already done a structural simulation for this. We have created an immovable support in the very bottom and created load conditions over the upper edges of these very high sections. So as I just go to file info, you can see within 16 seconds, the SimSolid was able to solve this very model. It's quite large model and we were able to solve this model in very short duration of time. If I just go to displacements, we can view the displacements as well. If we want stresses, again, we can have stresses over here. We can see where is the minimum and the maximum conditions of stresses. We again have just to pick a point and see how things are acting, or say what are the forces on the different bolts that we have in here, and would that bolt be able to take those forces or not. We can see over here. Again, we have the reactions on the different supports that we can see over here and save them to CSV if we need them for further processing. Apart from this, if you want to see the response of a model in a model analysis, we can just see how much time it took. It just took 55 seconds to find 9 modes for this very model for above 2,000 parts. So we just go to displacements. You can have the frequencies over here, as you can see, for the 9 model frequencies. We can save these clips, or we can save these from our bookmark browser if we need them for our presentation work or something like that. Apart from this, we have model participation factor over here. You can see which mode is affecting in which direction mainly, or if we want to have a histogram of those, we can have those, say, for X or Y and for Z as well. So we have the model participation factor over here. We also have effective mass and cumulative mass. If we want to have those data, we do have that also in our solver. Now, after model analysis, we have, as I've told you, that we have dynamic transient analysis as well. So if we have a time series data, we can go for transient. If we have a frequency data, we can go for frequency response. Say I currently have a time series data, I'll just go to transient. I'll just give how much time seconds I want that analysis to perform, and other parameters if you want to change the damping ratio. So I'll just keep it as it is, press OK. So over here we have dynamic transient analysis. We can just go ahead and define the time functions. In time functions, we will be having different time function as default. Say we have triangle, rectangle, simple sign. If I just click OK, it will create a function. Or if we just have our own, we can just delete all and just import a CSV file. Currently, I have a time series data, so I'll just import it. As you can see over here, this is say earthquake acceleration or anything like that. We have a high peak at 12 point something over here. I'll just press OK. And now we have other options, say what kind of other condition that we want to put in. We want to put in pressure. We want to put in force or displacement. We want to put in remote load or anything like that. Currently, I just want to put a brake excitation. I'll just say acceleration. What is the amplitude? Say I want the amplitude 1 and the direction also in x direction only. As we have defined the time function before, I can select the time function and press OK. Now I'll click the solve button. Within couple of seconds, this dynamic transient analysis will also be completed. Just wait a few seconds and here we have the results. So it just took 10 seconds to solve it for dynamic transient analysis. Now we can just move over and see our results. What are the displacements? It will evaluate the peak response. It will take a few seconds and give us the results. So here we have the results. As we have the peak at 12 point something, so is the displacement is highest at that very time period. Now we can just go ahead and see how our model will respond in various time frames. Or we can just show the peak at what time the peak will appear. Apart from that, we have stress, strain, velocity, and acceleration as well. I'll just go ahead and see what else can we get out of this model. So in dynamics reaction, we can, for single part, we can calculate what it's happening in the force magnitude or force direction. Say I want Fx in this value component, I can click evaluate and we can have the whole data, time series data of the response of the structure. Or at any connection you want to evaluate, what the condition is, you can evaluate that very connection as well. So I want at this very place, I can evaluate the force, Fx, Fy, Fz, and force magnitude as well. We also have the features to take out data for moment, Mx, My, Mz. Now that's about dynamic transient. Now, apart from this, we also have fatigue analysis built in SimSolid. In fatigue, we have SN time, SN sequential, EN time, and EN sequential. So if I'll just calculate the SN time over here. So if I just go over here and show you the results for our load case, I'll selected a channel. This is the channel which can be input from here. And we have the time event that we have matched the channel to the structure load case of 1. And we have just have those results. So for our results, it shows that, yeah, we can go ahead and the model is for this very load case, it's quite perfect. It is not going to fatigue for 1e to the power 20 cycles. So yeah, that's all. And I just wish to show you one more thing in our previous model. Over here in the pull-up bar, I just want to pull in one more thing. And I have told you that the SimSolid automatically knows what are the bolts and connections. So if I just, in this structure analysis, I want to say add a nut tightening. I just need to click on nut tightening over here and just select the nuts on which I want to give the tightening. And get the pitch, say I have a pitch of 1 and how much you want to turn, say 0.1, and get OK. Just delete this one and I just click solve. So we will have the results for nut tightening over here. You can see how many nuts are tightening. Apart from that, if you want other forces on nuts and bolts, we can see from here, and also the reaction forces. Apart from this, say you want to have multiple load cases at once. Say for fun's sake, you want to see how will my model behave. Say a person is hanging in this direction as well as in this direction. So you need to create another load case for it. We have a post study over here in which we can do structural superposition. As this is a linear analysis, I can just select the analysis that I want to reposition, superposition. I'll just click solve, and within seconds, the displacements and the stresses will be superpositioned and added up. So yeah, that's all from my side. If you guys have any questions or anything, yeah, please feel free to ask.
Yeah, Ali, we already got one question here from one of our participants. The question is, when you're defining the connections, like what type, like when it's automatically defining the connections, like what type of connections is it selecting? Are they glued or are they sliding? Like what is the type of connection that you're getting basically when you're doing that?
Mm-hmm. Yeah. So basically, when we just create automatic connection, is try to identify what type and how the bodies are placed, and automatically characterize some as bonded and some as sliding. In the cases of nuts and bolts, many places it will give the sliding contact, and for other structural to structural connection, it will give the bonded. Although you have a full ability to change this connection in any point in time, say you want to just change it, you can just go and say edit default connection type. In edit connection type, you have multiple features. That is, you want to disable the contact, or you want to have sliding without friction, you want to have separating or separating closing. So anything like that, if you want, you can just change it. But for the initial phase, if you're creating automatic connection, it will be created bonded, and you can just go ahead and create welded connections as I showed in the next model. And it's quite easy.
Okay, so what you're saying in a nutshell is you can define, it'll identify the bonded connection, the type of connections, and then after, if you need to, you can always modify them individually, essentially.
Yeah, whenever you want.
Wonderful. Okay. The next question we have is one of our participants was asking where the models were coming from. Like what type of models are you importing? Are these from SolidWorks, or are these from like different file types? So yeah, I think the question was, are these from SolidWorks, or what type of files are they?
Yeah. Actually, I am not aware of from which 3D CAD software they are, but they are XT Parasolid file. But if you want to export any model from direct CAD, it's quite possible. If you want to import it, say from SolidWorks, we do support SolidWorks Direct. If you want to import from UGNX, from Inventor, we have directly connection with this CAD type. You can directly import these into SimSolid, and they are properly supported. Yeah.
Okay. Okay, wonderful. Thank you. The next question we have is basically, I think the question is how are the for safety, making sure that these results are accurate or good. How are these simulations verified? Like, how do you make sure that the simulation results are correct? Like, how do you know that these simulation results are accurate? I think is the question. I'm paraphrasing here, but I think that's the question. So yeah, I think the question is just like, how are you making sure that these results are actually accurate? Yeah. So
yeah, SimSolid a great tool for a global level if you're searching for stress and strain. And over here, NAFEMS has conducted a separate independent research on how much the differences is between SimSolid and say FEA solver. So over here you can see the discrepancy is quite less. So the accuracy you can see is 90 to 95%, more than 95% if you just go by these results. So the software as a SimSolid as alone, it has been benchmarked with NFMs. Apart from that, we have a SimSolid verification manual.
And Ali, sorry to continue, but just to make sure, for those who don't know, what is NAFMs and what is NAFMs? Like what do they represent?
NFMs, I guess they independently verify how FEA solver works, or what are they accurate or not.
Okay.
So over here they are telling us that the SimSolid as a solver is accurate within these range. So you may be consider these at 97 to 98% in these very cases.
Okay. Okay, wonderful. Okay, good. I think the next question I'm reading here in the chat, but I don't quite understand. It says, how well does SimSolid perform the same type of analyses we've seen today with isolators in the design?
Actually, I didn't get what they mean by isolators. Greg, do you have any idea on isolators?
It looks like his mic's not working. The only thing I can say about isolators, this is the only thing, is it looks, an isolator would probably isolate one part of a structure from another part of a structure. So I would say that as long as you model the physical behavior, give it the right material properties and the right connections through the isolator, then you could, like you have like a rubber block or something like that between two bits of steel or something like that. As long as you've done the contacts properly and have the material properties defined properly for the rubber, then SimSolid is going to treat it just like any other part with any other material characteristic, and should handle it just fine. The only other thing I was going to just mention while I'm talking, NAFMs. It is sort of a global society for CAE and simulation engineers in all sorts of different physics realms. They're sort of like the leading society, and they're also becoming sort of a certification agency for finite element simulation. So one of the things they do, and they're solver agnostic, so they work with all the different solvers. But what they do is they produce these benchmark. One of the many things they do is produce these benchmark problems, and then have like all the different solvers out there in the world sort of, because you have a theoretical answer, will work towards solving these problems, and they can compare the accuracy. So what they are is they're sort of solver neutral. They're not tied to any one company, so they're sort of given impartial flavor to these things, so you can compare sort of the accuracy of the solvers from one company to another. And I mean, Ellie, you were very cruel to SimSolid. It's much more accurate than the 95%. What it is, as you said, it's a part-based solver, so it sort of does a part-based equilibrium, part-based stresses. So where SimSolid doesn't always give you the best answer is where the local stress is designing it, and on your benchmark there was the stresses around the hole, because SimSolid doesn't go in and put a whole bunch of math to capture that, because like I said, it's not meant to capture the details, it's meant to capture the global part behavior. So it's really accurate when that's the type of problems you give it. It is, like I said, it's never really meant to be a detailed stress solver, so that's where the numbers sort of bring the average down, but that's not necessarily fair. Is that cool?
Thanks, Greg. We got here during the let me see here. During the demonstration of transient problem, I didn't notice you defining the enforced motion location. How did it automatically assume that, or did I just miss it? So I'll read that again. During your demonstration of the transient problem, Ali, this participant saying, I didn't notice you defining the enforced motion location. Like when you did the enforcing citation, did it do it automatically, or did you just assume the location?
Yeah. First thing, our transient analysis took in data from our model analysis over here. So it knows that we have a constraints over here, we have a movable support over here. And second thing, we haven't applied a load over here, we have applied base excitation. my camera for the bandwidth purpose. So over here we have the base excitation. I haven't put any load. I try to simulate it. Say we have a earthquake that has such an time series amplitude factor. It's based on time series. So for an earthquake, we need not to define the load. You know, it will be acted in whole of the structure.
And the excitation, I guess, is being applied to the actual like mounting locations. Is that correct, Ali? The excitation.
It would be on a Greg, correct me if I am wrong. It will be on the whole structure. Say if a structure is under an earthquake, all right. So it will shake at all the points. The force will be acting in all the points X, Y, and Z direction. It is not that the force will be acting only on the top. In all of the structure, will feel that one response. So over here we have just given the direction that one response we want in X direction. Although if we want in Z direction, Y direction, we can signify from over here. And that's why we didn't provide anything like that. Greg, is that right?
I'm embarrassed to say that I don't know much about dynamic transient analysis.
Mm-hmm.
Usually, you would have, I would have said that in traditional FEA, comparing it, the base excitation would have gone into where you put your boundary conditions to restrain the model, and that's where you would usually see it, sort of at the base, because it's a base excitation. So what happens is you wiggle the bottom, and then the rest of the structure wobbles in accordance, right? So it's not a uniform acceleration to the entire structure, right? It's put in at one point, and then the vibration, or the input moves its way up to the structure based on its stiffness. So I would have said, but I said I'm unfortunately, yeah, like I said, embarrassed to say I'm not too familiar with dynamics.
Well, I tell you what we could do is we could take this offline.
Why don't we take that off?
Answer
exactly.
Offline if you guys like.
Yeah, so just note who said it, and then we'll follow up with them in the details.
Yeah,
so normally, yeah.
And Kevin, for the fixed constraint, as I've told you that this dynamic transient analysis is directly connected to our model. As if I just go over here, if I just go in transient, we need to define the model analysis to link it. So it's working on the model analysis. So it took those boundary conditions from the model analysis.
There you
itself.
go. That's what it did. Yeah.
I guess I answered this one question.
Okay. The next question we have is here it is. It says, I know one of the benefits of SimSolid tool claim no meshing, which is a really good question. But I am assuming it is just automatic and done in the background. What if I wanted to see the mesh to be able to troubleshoot the model is basically the question. So, I'm sure like you guys have done some simulation, like when you do meshing, you can kind of zoom into the mesh and whatnot. So Ali, if you needed to troubleshoot this model, wanted to look at the mesh, it's the question, how would you troubleshoot that?
So over here, we do not interfere. You cannot, because it is not mesh based. So you cannot get into the mesh or change the mesh. Although in the structural setting, you have the adaptive solutions. As I've told you in the starting, that adaptive, as the solution progresses, it adapts to and add the degrees of freedom in various bodies within the model. So there is some problem. If there is some model problem over here, you can just increase or decrease the number of adaptive solutions over here. Also, there have other features. Say you have thin solids, or you have features such as holes and those things. For those, you can adapt from over here. So you can adapt to thin solids or adapt to features. Also, the refinement level can be controlled from here if you want to increase it or if you want to keep it standard. So we do not have any interference of the mesh. In the results, we do have, say you want to just refine some of your results. I'll just go over here. Say if you just want to refine some of your results, so you can just right click over here, go to result plots and click refine, and it will refine. the contours. You want to add anything, Greg?
No, it's fine. So there's another thing is there is no mesh. Honestly, there's no mesh. There's no mesh in behind the scenes. There's no mesh to manipulate. SimSolid is truly a meshless solver. Now, it works off of basically the same principles as finite element analysis, but as I said, in traditional finite element analysis, we discretize the structure into these tiny problems with simple shape functions, right, that describe the behavior called elements. What SimSolid is why do we bother with these elements? Why do we solve a whole series of little simple problems and then add up the answer? Why don't we just solve for the entire part? So what SimSolid actually does is it goes in and basically applies those shape functions to the boundaries of all of the parts. So it goes in, adds those degrees of freedom. It goes in and locally refines and adds certain degrees of freedom, certain translations, certain rotations, and only the air in the orientations it cares about. And then it does an adaptive path to match the error condition with its prescribed boundary of that part. And so it goes in, and these are these passes that Ellie's referring to, is it's going through and adding more complexity to the math. So basically what you're, in effect, in finite element terms, you've created one giant element that is the exact shape of the part. Right? So there is no, it is truly meshless. And so once you've created that, it solves it just like finite element analysis using the same method behind the scenes, but from a very ridiculously 100th order polynomial equation that describes the boundary of one, of the edge of one part kind of thing, rather than a simplistic shape function, of a linear relationship between two nodes on a hex element or something to that effect. So now the irony of that, what Ellie just sort of alluded to though, is in order to show you the results, because you've got these really complicated math, what SimSolid actually does is it creates a visualization mesh. And then applies the results at those nodes of the mesh, and that's what Ellie was doing with refine. But that refining to basically get more points to interpolate between to get pretty colors, that is not a solve mesh. That's just a visualization mesh at the end. Yeah, but truly behind the scenes, the math is meshless.
Thank you, Greg, and Ellie, appreciate that. Okay. I guess we're near the end of the webinar, so I guess we'll close everything out unless no one has any other questions. I just want to say thank you so much for attending. Like I said before, feel free to reach out to Ash if you have any further questions. We'd be happy to set up a personal webinar or demonstration for you to answer any technical questions you guys have about this. For those of you also that already currently have Altair units, you likely have access to this package already. So if you want help at installing and setting up your software to be able to start utilizing it and having us provide you training set up for learning how to use this, typically the learning curve on this is about less than a day. So we can usually get you set up pretty quickly if you wanted to start exploring this package. Thank you so much for joining. Ali, really great demonstration, and Greg, really appreciate the support. Thank you very much, and we'll sign off. Have a good day.
Thank you very much, guys. Have a great day.